Okay, we're going to take off and go straight into Investigation 12B, Hurricane Wind Speeds and Pressure Changes. This activity is going to be using data from Hurricane Wilma. Hurricane Wilma was also another tropical cyclone that occurred in the 2005 hurricane season. It occurred, I don't know, a month and a half or so after Katrina. All right, let's look down here where it says Wilma. Number 1, Table 1 gives at 6-hour intervals the position, central pressure, and maximum sustained wind speed of the tropical cyclone that evolved into Hurricane Wilma during the 17th through 25th of October 2005. The central pressure of the system at 00, 06, 12, and 18 universal time is graphed in Figure 1. Universal time is just based on a set place. So graphed in Figure 1 with the pressure scale to the left. From Table 1, at what October 2005 date and time was the central pressure the lowest? Okay, so I'm going to go ahead. The graph that you have to look at is actually on the back of this paper for me. So we're going to flip over, and here's the graph. And I'm going to look through my numbers for central pressure. Scan, scanning, and it looks like this right here, 882, is my lowest pressure reading. Okay, so I go over, and I notice that that occurred at, it was on the 19th of October, 1200 UTC. That's the time. Okay, so that is what you need in order to answer question number 1. Okay, it occurred on the 19th at 1200 UTC. Number 2, at this time the central pressure was what? Well, we just looked at the scale, but if you've forgotten, it's on there. The central pressure was only 882 millibars. And actually, you guys, I think, did some poking around and looking at Wilma on your scavenger hunt, and so I think you may have already seen this pressure reading. This most intense condition occurred as Wilma was slowly crossing the warm waters of the Caribbean Sea east of the Yucatan Peninsula. The Yucatan Peninsula is part of Mexico, like where Cozumel and stuff is. Okay, let's hop to number 3. From October 18th at 1800 to October 19th at 1200, the total pressure fall was, I don't know, let's look. October 18th, 1800. October 18th at 1800. It was 975 right there. Okay? So 975, and we got all the way down to 882. So how do I figure out what the total pressure fall is? I just subtract 975 minus 882. So figure out what that is and pick the proper answer. Okay? And then on number 4, you actually use the answer from number 3 because you're going to figure out how fast was the pressure falling. Okay? The rate of pressure change is just going to be your total pressure fall from question 3 divided by the 18 hours that went by. Okay? So from this time to this time, 18 hours went by. So you're going to say amount of pressure change divided by the time, and that's how you're going to choose between these 3 answers. I'm not going to do it for you, but you are welcome to do it, and you can actually just grab a calculator and calculate that real quickly. Okay? All right, number 5, the most rapid deepening or lowering of Wilma's central surface air pressure occurred between October 19th at 00 and October 19th at 600, resulting in storm intensification that was how many millibars. So they're looking at what single change from one measurement to the next was the largest. Okay, so look at October 19th at 00 to October 19th at 0600 and figure out how many millibars changed in that amount of time in millibars per hour. Okay, let's see, 19,000, you had 946, and 1900 at 600, you had 892. So again, you're going to use that same formula, and you're going to say 946 minus 892 and you get that number. And 6 hours have gone by, so it's going to be however much the pressure change was divided by 6 hours, and then pick your answer. Using the wind speed values from Table 1, plot on the Figure 1 graph the wind speeds every 6 hours. Use the wind speed scale along the right side of the graph. So what you're going to do is you're going to take this information and you are going to construct a graph. Plot each value with a dot, and when completed, connect adjacent dots with straight lines. Please color it red if possible. The line that they did for you is the central pressure, and that's already been plotted for you. And you can go over that maybe with a blue marker, but the one that you plot is going to be done in red marker. Okay, the first 2 dots they actually did for you. Okay, so I'm looking at the graph now. This is the graph that you're going to construct. They've already done the central pressure graph. Okay, you are going to construct the wind speed graph. Okay, so the central pressure numbers are over here. Okay, and they used those. But on the other y-axis, that's where they plotted the wind speeds. So you're going to have to pay attention to this y-axis in order to plot your information. Okay? All right, so like I said, the first 2 dots have been done for you. Okay, so you do have 4 more questions to answer, 6, 7, 8, and 9. But what you need to do is you need to have your graph done before you can attempt to answer those questions. Okay. Look at number 8. I'm not going to actually, answer it. You need your graph done, but let me kind of walk you through it. It says Wilma's center crossed the tip of the Yucatan Peninsula in Mexico from about 00 UTC on the 22nd of October to 00 UTC on the 23rd. So it was about a 24-hour period. Place a bracket along the time axis at the bottom of Figure 1 graph to denote these times and label it with a YP, which stands for Yucatan Peninsula. This overland time was for the center of the storm, whereas extreme weather conditions associated with the system extended from its eye wall outward several tens of kilometers in all directions. During the initial several hours of the overland time period, the wind speeds generally increased or decreased as the storm's circulation responded to the increased roughness of the underlying land surface. Okay, so go back and remember what we said about what happens to storms when they move over land, okay, to help you answer number 8. All right, number 9, again, you really need to get the graph done first, but let's just walk through it. When its maximum wind speeds are greater than 64 knots, which is 74 miles an hour, a tropical cyclone is classified as a hurricane. Wilma moved rapidly northeastward from the Yucatan Peninsula before crossing the coast of southern Florida on the 24th of October at 10:30 UTC. According to the graphed data, was Wilma at hurricane strength when it made landfall in Florida? Remember, they're telling you it made landfall in Florida on the 24th of October at 10:30 UTC. So you need to find that time on your graph, look at the wind speed, and figure out whether it was at hurricane strength or not. Okay? At 12Z on October 19th, 2005, Wilma had a central sea level estimated pressure of 882 millibars. We've already talked about that. This was the lowest pressure ever recorded for a hurricane in the Atlantic Basin, making it by one measure, at least, by measuring pressure, the most intense system in the Atlantic so far. And like I said, there have been some record breakers in some ways from 2017, but this was written before 2017. So you actually have to complete part of 12B, obviously, on your own. But get that finished, get the graph drawn, make sure you do the little label, the YP, because you need to put a little bracket during that time period. So make sure you do all that before you finish it and turn it in.